Good morning, good afternoon, good evening, ladies and gentlemen, and in today's video we're going to look at various examples using sinusoidal functions. So first and foremost, if you were given a graph or some data, how would you end up making your equation? So let's take a look at this example. So you're given this example and you need to look at some certain points here. So right away you can see that the maximum here is 3, because that's the biggest point. And your minimum is -1. So how would I create my equation? Well, you need to find your period first. And if you remember, your period you can find using the k value, which is always 360 degrees divided by basically what your period is. Now you can see your period here. What's happening here? Well, you start from up, you go to down, you go back up. When does it go back up? At 10. You start up, you go back down, you go back up. When did you go back up? At 20. So you're going in intervals of 10. So my period would be 10. So what's my k value? You're going to get 36. All right, so, and then what is my amplitude? Well, you can see here if you were to use your max and min. So let's do this. Let's say I got my y equation. So my max and min, you remember it should be max plus min divided by 2. That's 2 divided by 2, which is 1, which means this is my axis. And remember, anything that's above it and below it, they should be even. So it goes up by 2 and it goes down by 2. So my amplitude is 2. Now it starts from the maximum, and we know the ones that start from maximum is always cosine, because it starts from the maximum, which means my final equation should be h of t is equal to, amplitude is 2, cosine of 36t. And we know if this was a normal graph, it should normally be at my amplitude, right? Which means my max should be 2. But because it's 3, I know I had shifted it up by 1. All right. Now, what if this was also a sine function? Well, how would I make it a sine function? By extending it more to the left. So if I extended it to the left, then that would mean I could make myself a sine function. So my sine function, you're still going to have amplitude 2, you're still going to have this sine, and it's going to be still 36. But we had shifted it to the left. And as you guys know, the left, how would I write it down? You'd write it down as plus. And it's about by 2.5 here. Yeah, by 2.5. Because you know that each one here, if this is 5, then this over here would have been 2.5 when it hit the 0. So if I want to get back to the 0, it would have been at 2.5 plus 1. So those are the two different functions I can get from this graph. Let's take a look at another example. Okay, so let's take a look at this example here. So again, you should always try to pause these examples and try it out yourself. So it says here, a sinusoidal function has an amplitude of 2 units, a period of 180 degrees, and a maximum at 0, 3. Determine the equation of this function and represent it 2 different ways. So the first thing you always want to try to find out is your k value. So find k. That should always be your first step in these matters. So k is always going to be 360 degrees divided by the period. Well, it already tells me my period is at 180 degrees. Okay, so that should give me 2. So k is 2. Now the second step, if I needed to, would have been to find my amplitude, but that's given to me. So I know A is equal to 2. That's my given data. I also know my max is at 3, because it's telling me I have a maximum at 0.3. So if my maximum is at 0.3 and my amplitude is 2, but my max is at 3, the maximum should usually be what my amplitude is, but the fact that it's not means this had to have been shifted up by 1 from the amplitude, which means we have a shift of +1. So we have that information, so we can start writing it. Now it doesn't tell us whether it is a sine or cosine, which is why it says represented in 2 different ways. So one way would be 2 cos 2x plus 1, okay? Or if I were to move it to the left and make it a cosine function, or sine function, sorry. Now remember, standardly, whenever you're making these graphs, you're usually going up to 360 degrees, or in this case, 180 degrees. So 180 degrees divided by 4 is 45. So if I wanted to shift it to the left by 1 part to make it into a sine function, then I would have to do plus 45 degrees. And just like that, I have represented 2 different ways. So let's look at another type of example. Okay, so let's take a look at this example here. So it says here, the moon is always illuminated by the sun. How much of the moon we see depends on when it is in its orbit around the Earth. The table shows the proportions of the moon visible to southern Ontario on days 1 to 74 in the year 2006. Okay, so they want you to use this data to make an equation for the function, to find a domain and range, and to determine something in the future. So let's do that. So remember, first step always is to find your k. So you know k is always going to be 360 degrees divided by your period. Now, how would I find my period? Well, you pretty much already see that the period goes by 29. Okay? So you have a period of 29. And when you divide this out, what are you going to get? Well, I'm going to divide it by 29. Well, you're going to get a decimal number. So at this point, I would actually leave it as 360 degrees divided by 29. What else do I have? Well, looking at my data, I can see my amplitude is 1/2. Remember, you can find that using your max plus min divided by 2 and then finding out how much over it is for your max. Okay, and my C value is 1/2. Again, looking at your max and looking from there. Okay, so let's take a look here. Now, if you're having trouble seeing where the 29 and the other things are coming from, just remember the way we always make our graphs is we go from the first 0, then the maximum, then the next 0, and then the next minimum, and then finally the last 0. So, when's the first 0 here? Well, the first 0 here is at 29. Okay? And you can see the next one is 29 later as well. So, That's how you have to look at it. All right, so let's go from there. Let's make our equation. So in this case, you just need to plug and play. My amplitude is 1/2. Let's go with sine here. 360 divided by 29. Now, if it's sine, I don't know how much it might have shifted to the left or right. So I need to put a t there. And then plus my 1/2. Okay? Now, obviously, this is true for if it's at... This is for when y is equal to 0, at t is equal to 0, or t is equal to 29. Okay? That's when my y value is 0, when my t is 0, or my t is 29. Okay? So let's solve from here. Let's go from there. So I know at 0 you're going to have, let's use a different color here. So you're going to have negative 1/2 is equal to 1/2 sine 360 divided by 29 t minus d. And if I want to get t minus d by itself, I'm just going to have to shift things around here. So remember, the first thing you do is get rid of fractions. So you're going to multiply both sides by 2. Okay, everything here is multiplying, so you don't really have to multiply everything there. So the 2's will cancel out, leaving me with negative 1 is equal to sine 360 over 29 t minus d. All right. If you want to get rid of the sine, remember you got to do sine inverse. So I'm going to do a little bit of a side here. So sine inverse of negative 1 is giving me 270 degrees. Okay. So that's going to give me 270 is equal to 360 over 29 t minus d. Multiply both sides by 29. So you're going to have 29 times 270. It's going to give you, it's going to continue this over here. So once again, you're multiplying both sides by 29. It's going to give you 7,830. And then you're going to divide both sides by 360 to get rid of this as well. So divide by 360. And that's going to give me t minus d. So t minus d, if I round it, it's going to give me 7,830 divided by 360. It's going to give me about 21.75. Okay. So in this case, if t is equal to 0, then d would be negative 21.75. So let's put that into our equation. So therefore, y is equal to 1/2 sine 360 over 29 t minus minus, so that means plus 21.75 plus 1/2. Okay. Now, what if t was 29? Then d would be 7.25. So I have a second equation there. Y is equal to 1/2 sine 360 degrees over 29 t minus 7.25 plus 1/2. And that's it. Let's continue this in the another slide here, just so we can find the domain and range and the last part here. So they asked us for domain and range. So the domain, well, what can t be? Well, you know t has to be greater than or equal to 0. Remember your maximum here and your minimum. So my minimum here is always going to be t is greater than or equal to 0. Because if you'll notice, you can't have negative time. So because I can't have negative time, then yeah, your smallest time is 0. And my range, remember your range goes from your min to your max. So my min, if you'll notice from the graph, is 0. My max, if you'll also notice from the graph, is 1. Now part C was asking us to use the equation to find out what proportion of the moon would be visible on day 110. So basically they're telling me t is 110. Alright, so let's go into that. So you have my equation that I made from earlier, 1/2 sine 360 over 29. Now instead of the t, you're going to put the 110. Now you can use either of the equations. You can use the first one or the second one. I'm going to use the first one. So plug that into your calculators, and you should get that it's approximately 0.37. All right. So that's how we can make sinusoidal functions depending on the situation. So how then would we solve problems with them? So this will be the end of part 1. We're going to take a look at part 2 now.